Welcome to my video. My name is Abdullah Al-Rubai, and today I will present to you my Adruino project, the liquid dispenser. My advisor is Dr. Kong for mid-program project. Alright, so I'm a sophomore at Delaware State University. I'm majoring in computer science. I'm interested in quality assurance engineering and QA testing. So my motivation for this project was given to me by Dr. Kong, where we were given the option to make a project using Adruino kit. And what motivated me for it was mechanical designs, water mechanics, motion sensory robotics, and just the mechanics of using the motion sensors to make the water go from the pump to the cup for a specific amount of time. So the benefits for this project, it gives you less contact where you won't have to touch anything in order for your water to get to you other than your cup, of course. And it's more efficient that it will fill out your cups without people, because especially in the time of the pandemic, we don't want a lot of different people touching the water hose, especially that it's water one after one, and like they're gonna have to sanitize their hands and everything with that. So my project doesn't give you to do all that. It just, you put in the cup, the motion sensor works, and everything starts going slowly. The water flows into your cup and you're good. Alright, so the problems and solutions. The problem with the normal liquid dispensers in the time of pandemic, as I explained earlier, you have to turn it on and off, switch it on and off. My solution gives people the ability to turn it on and off without touching it, using the motion sensories. Alright, so my 3D design. The liquid dispenser is primarily for drinking without touching the hose. It works through motion sensor located in the silver tube over here. The motion sensor is going to be right over here. So when the sensor approaches the water tube, will pump water through it, allowing water to pour in. The smaller box on the board is containing the circuits, connectors, and the connections to both the sensor and the DC pump. So let me just explain it to you simply. So this 3 designs were incomplete. That was just me showing you guys the thing before adding the curtains in. So basically in this light blue circle thing over here, or it's a glass under it, or it's the motion sensor. The motion sensor is connected to a DC pump that is right under here in the container, and it's also connected to a motor, stepper motor over here, servo motor under here, and the Adruino kit in this box over here. When you rest your cup, the motion sensor works, pumps water into your cup. Here, this goes up and the servo starts moving. So maybe let me show it to you here. Alright. Okay. So as I explained earlier, you put the cup here, and as soon as you put the cup, what will happen is this. Okay, this is a rope. It doesn't look like that because I had to adjust some things for it to look like that, but like it's a rope. The rope is connected to these 2 things over here, and it's connected to a servo motor on this side. Once the motion sensor works, that it's connected to the stepper motor, it's gonna go in clockwise in one direction for a little bit, and when it does that, it's gonna move this in this direction, in the right direction, moving the rope up, which gonna make this cover, that is a clear cover, go up here, stopping your hand from actually going for the cup. And then the DC pump will start pumping, and it will pump water in your cup. And then after the loops where it stops, and I will go over the code in a minute, the stepper motor moves in the other direction, making the curtains go down. At the same time, my servo motor over here will be moving in a circular direction. It's not actually connected to anything, it's merely for decoration, but I added it still because it gives you more look into it's a water sink, so it gives you a look for it. And in here I have my Adruino kit, my electricities that is connected, and it's going to be connected to everything else. Alright, so this is my 3D design for if people want to look more into it. I will be giving all the links in the description, but I just wanted you to see the design close. Alright. The connectors of the diagram of the dispenser. So basically, of course, this is not the actual one. This is the ones I used. It was my references that helped me go through it. So of course, one of them was this. It was for the stepper motor, and one of them is this for the servo motor, and this is for the DC pump and the LED light. Basically, the servo motor was put just like that, except for I put it just like that. And the stepper motor was put, except these two connectors were connected to the Adruino kit, and it was also connected to a 5-volt connector relay that was connected straight up to electricity. For the DC pump, I didn't actually use this relay. I instead connected it to the Adruino kit, to the wire, and to the wires also that is connected to the 5-volt DC. All the references will be put in the description, where it's going to be way easier for you guys to connect everything together. Okay, pros and cons. My products gives you a contact-free drink without worrying about sanitizing or washing your hands afterwards. Also, don't worry, I got you with a product cons-free. The tools I used, of course, the red water container, the DC pump, the Adruino kit, the motion sensor, the liquid tube, plywood, water tap, some jumper wires, a servo motor, and a stepper motor. All the things that you need to buy will be in the description. If you go down to the link, it will show you where you could get everything and from where. Also, I added some references just in case you don't want to do exactly my project, you want to do some other project. There is 2 links for one without the curtains, and there is a link for another project for the stepper motor. Okay, so my code, this is link to my code, which is right here. Okay, so let's go over the code real quick. So basically, this code is on the Adruino app that you have to download on your MacBook. So first of all, you have to define the trick pin and the echo pin for the motion sensor, the LED light. The water pump was using pin number 8, and you have to include 2 libraries, one for the stepper motor and one for the servo motor. Constant in range is the range of inches where your hand, if it goes into the range of this 8 inches, the motion sensor will start working. The end pass 0 and the servo 13, the pin for the servo motor. The constant float serve steps per revolution, and the gear rate 64 is for the stepper motor, and stepper per out revolution equals to steps per revolution times gear rate. This is the steps required. This is for the stepper motor, where I used pins 10, 9, 11, and 12. This is the void setup for my serial pins, my trigger pin for the motion sensor and the echo pin, the LED light and the pump, the water pump. And here I set the digital light for the LED and the pump. And now we go for the servo. It's attached to pin 13500 and 2500. And there's a loop right here for the inches durations and for the motion sensors, and the trig pin for the motion sensor. The duration is in echo pin and should go high. This is the inches and the centimeters conversions. The conversions right here, and this is our main if statement. So if inches, which is defined up there, 8 inches, are in range, if inches in the range of 8 inches, that means hand putted. The steps will start at the speed of 400 steps required. So basically at this point, when you put the cup, the stepper motor will go in one direction, allowing the curtain to go up. Then the LED light will work and the pump will start pumping. And then we have this two for loops for the stepper motor that doesn't go in one direction all the way, so it's gonna go in, it can't go continuously. The servo motor, you're gonna have to buy an updated one, but for my normal servo motor, it moves in 180 direction in one side and then stopped and went in the other side in 180 direction. These two for loops, as I explained, it was merely for decoration, so I didn't have to go over it too much. The rotate anti-clockwise for the stepper motor, and when it goes in the other direction of the clockwise, this way it puts the curtains down and delay and everything stops. No hand put it, LED high, pump low, delay. This is the long microseconds to inches, 10 microseconds, and yeah, this is for basically for the speed. And this is my code. I will be putting it in my blog that will be put in the description to make it easier for you guys to look more into it. Mechanics. This is mechanics of my video. This is the motion sensor, the Adruino connected. This is my servo motor connected down here. I'm gonna have more pictures explaining how it looks like. And this is my DC pump and how I connected it so it stays steady. And yeah, this is the mechanics. So basically, as I explained, you put the cup here, motion sensor starts working, the DC pump starts pumping, and right before that, the stepper motor starts going up, and then in one direction it takes the curtains up, and then one direction takes them down. Servo motor gonna be moving, and then everything stops and you just get your cup. Alright, this is more pictures. This is the servo motor. The LED light is right up here, blue LED light, and as you see, you put the cup, it goes up here, starts pumping water, it goes down, it stops, and you're ready to take your cup. This is for your references. It's a YouTube video. Yeah, I'm sorry about that. So this is the ones I used. It gives you everything you need. The code and how he connected it. So my project is similar to his, except for the differences of the two motors, the amount of time it pumps, and everything else. This is just the GitHub and the code for his project, and this is for the stepper motor, to help you go over the stepper motor and everything else. For more information, you could contact me at my phone number, my email, or my LinkedIn. So the video presentation is just, let me go over it for you guys. It's just, yeah, it will also be added in the video. So we don't have to go over that. And thank you for watching and have a great day.